Stop looking at the burning tank cars. That is exactly where they want your eyes. If you think the disaster in East Palestine was caused by a single overheating axle, you have bought the corporate press release hook, line, and sinker. The derailment of Train 32N wasn't an accident. It was the mathematical result of a policy voted on, signed, and sealed years before the first wheel ever touched the track. This wasn't a mechanical failure. It was a successful execution of a business plan. They told you it was a tragedy of circumstance, a freak alignment of physics and bad luck. That is a lie. The disaster was locked in the moment a boardroom decided that safety redundancy was an inefficiency to be eliminated. We are not here to look at the smoke. We are here to look at the signatures. You're watching Rust and Thunder, where the iron never forgets. If you value this depth of analysis, subscribing ensures you don't miss the next investigation. To understand the mechanics of this catastrophe, we have to ignore the media circus that descended on Ohio in February 2023, and instead open the dusty, unglamorous files of the National Transportation Safety Board docket. The story the public received was simple. A wheel bearing on the 23rd car overheated, the axle failed, and the train jumped the tracks. It sounds plausible. It sounds like the kind of wear and tear failure that is inevitable in a heavy industry. But when you overlay the timestamp data logs from the locomotive's event recorder against the internal policy documents of Norfolk Southern, a different narrative emerges. The bearing didn't just fail in a vacuum. It was allowed to fail. It was nurtured into failure by a system designed to ignore it until the very last possible second. The train itself, designated 32N, was a rolling testament to the modern philosophy of precision scheduled railroading, or PSR. In the industry, they don't call these trains anymore, they call them consists. And this consist was a monster. It stretched nearly 2 miles long, weighing in at roughly 18,000 tons. It was hauling a chaotic mix of freight, frozen vegetables, malt liquor, paraffin wax, and of course, vinyl chloride. But the most dangerous thing on that train wasn't the chemical payload. It was the operational logic governing the crew. The NTSB hearings revealed that the crew of 32N was operating under a surveillance system that had been systematically blinded. The railway network is dotted with wayside defect detectors, hot bearing detectors, or HBDs. These are the roadside sentinels, the robotic eyes that scan the passing wheels for infrared heat signatures. In a sane system, these detectors are the fail-safe. They are the shield. But in the modern railway boardroom, a detector is often viewed not as a safety device, but as a bottleneck. Every time a detector flags a train, the train stops. When the train stops, the velocity drops. When velocity drops, the operating ratio, the holy grail of Wall Street metrics, suffers. So how do you fix the problem of detectors stopping too many trains? You don't fix the trains, you change the rules for the detectors. The records show that the bearing on car number 23 was heating up for miles. It was screaming for help. As the train passed through Salem, Ohio, roughly 20 miles before the derailment site, the bearing was already significantly hotter than the ambient temperature. The HBD at Salem recorded a temperature rise, but it didn't trigger an alarm. Why? Because the threshold for an alarm had been set so high that a bearing essentially had to be on the verge of disintegration before the crew would be notified. The silence in the cab of 32N wasn't due to a lack of data. The data was there. The silence was a policy decision. This is where the concept of narrative lock-in begins. Long before that night in February, the corporate leadership established a critical threshold for stopping a train. They calculated the risk. They ran the numbers on how many bearings might fail versus how much money would be saved by keeping the fleet moving. They set the alarm threshold at a staggering level relative to ambient temperature. The bearing on car 23 was literally melting its internal components, generating friction heat that turned the steel white-hot, yet according to the computer, everything was green. The crew plowed forward, unaware that they were dragging a ticking time bomb because the machine had been programmed to lie to them. The tragedy is found in the gaps. Between the detector in Salem and the detector in East Palestine, there was a critical stretch of track where the thermal runaway went exponential. Physics dictates that once a bearing seal fails and the grease purges, the heat generation isn't linear, it's vertical. The temperature spikes aggressively. If there had been another detector in that gap, or if the Salem detector had a more conservative safety margin, the crew would have hit the brakes 20 miles back. They would have set out the bad car in a siding, there would have been a delay, there would have been a repair cost, but there would have been no mushroom cloud. The boardroom vote that locked this disaster in wasn't a vote to derail a train. It was a vote to widen the spacing between detectors and to resist the implementation of newer predictive technologies that could spot a failing bearing before it reached a critical temperature. The industry calls this asset utilization. They argue that too many false alarms slow down the supply chain, but when you read the transcripts from the hearings, you see the grim reality of that trade-off. You see executives defending the spacing of detectors as industry standard, while the residents of East Palestine are left to scrub the soot off their siding. We have to look at the specific moment of failure through the lens of the locomotive's forward-facing camera. The footage, which has been analyzed frame by investigators, shows the train moving through the dark Ohio countryside. It is routine, it is mundane, and then the final detector in East Palestine shouts a warning. By then, the temperature reading was catastrophic. The bearing was hundreds of degrees above ambient. The alarm finally sounded in the cab. The engineer, following protocol, initiated an emergency brake application, but physics has no loyalty to protocol. The bearing seized, the wheel stopped turning. The axle, weakened by the intense heat, sheared off. The car dropped to the ballast, dragging the rest of the train with it into a pile of twisted steel and fire. The official report will list overheated wheel bearing as the probable cause, but that is a forensic simplification. It's like saying a man died from a fall without mentioning he was pushed. The bearing was the weapon, but the motive was efficiency. The narrative lock-in occurred when the railway industry convinced regulators that they could police themselves, that they could set their own temperature thresholds and determine the spacing of their own safety equipment based on economic models rather than engineering necessity. The hearings exposed a culture where the crew is the last to know. The conductor and engineer on 32N were experienced railroaders, but they were flying blind, trusting a system that had been rigged to prioritize movement over integrity. They were placed in an impossible situation, tasked with managing 18,000 tons of momentum while being fed sanitized information. When the alarm finally screamed, it wasn't a warning, it was a notification of death. To truly understand why East Palestine happened, we have to go back to the quarterly earnings calls leading up to 2023. We have to look at the aggressive reduction in workforce, the consolidation of dispatch centers, and the relentless drive to lower that operating ratio. Every technician laid off, every car inspector given less time to walk the train, every detector removed or spaced further apart. These were the votes. These were the ballots cast in the boardroom. And on February 3, 2023, the results of that election finally came in. The fire that consumed those tank cars was fueled by vinyl chloride, yes. But the spark was struck years earlier in a climate-controlled conference room where a group of people looked at a spreadsheet and decided that the cost of safety was just too high. They bet against the laws of thermodynamics, and for a long time they won. The trains kept moving, the profits kept rising, the dividends kept paying out, but in the railway business the house doesn't always win. Eventually the iron breaks. And when it does, it doesn't just break the track, it breaks the town that happens to be sleeping next to it. The disaster was locked in. The train was just waiting for the specific milepost where the bill would come due. Stop believing the accident narrative immediately. This wasn't bad luck and it wasn't a surprise. It was a calculated gamble taken by executives hundreds of miles away who bet that a bearing could run hot without turning a town into a crater. They lost that bet, but the people of East Palestine paid the debt. The reality is that Train 32N was a guided missile long before it reached the Ohio border, and the guidance system was a corporate policy that prioritized velocity over physics. We are not looking at a broken part. We are looking at a broken philosophy that decided exactly how much fire was acceptable on a moving train. To understand why the crash became inevitable, you have to look at the data streaming from the tracks in the hour leading up to the disaster. This is where the forensic timeline becomes damning. As the train moved east, it passed a series of wayside detectors, automated thermal sensors designed to look up at the passing axles and scream if they saw heat. But these machines are only as useful as the humans who program their trigger points. And the trigger points set by Norfolk Southern were not designed for safety, they were designed for efficiency. At milepost 28.3, the bearing on the 23rd car was already heating up. It registered 38 degrees above the ambient temperature. In the world of friction bearings, this is a whisper of a problem. It's a warning sign that the grease is breaking down, that the metal surfaces are beginning to kiss. But under the rules of the road, it was green. The crew in the cab received no alarm. The train kept moving at track speed, heavy and relentless. 20 miles later, at milepost 69.01, the situation had shifted from a whisper to a scream. The sensor read the bearing temperature at 103 degrees above ambient. Physically, the component was failing. The internal geometry of the bearing was disintegrating. The rollers were fighting against the cage, and the heat was rising exponentially. But here is the critical failure point. Norfolk Southern's internal policy didn't require the train to stop until the difference hit 170 degrees. Think about that margin. The bearing was burning at over 100 degrees hotter than the air around it, literally cooking the steel, yet the algorithm stayed silent. The boardroom vote wasn't a literal show of hands that night. It was a policy decision made years prior that established 170 degrees as the threshold for panic. By setting the bar that high, they effectively silenced the warnings. The computer saw the fire starting, checked the rulebook, and decided it wasn't hot enough to disrupt the schedule. If digging into these official NTSB transcripts and uncovering the mechanics of negligence helps you understand the reality behind the headlines, a like on this video ensures this data reaches more people who need to see it. Inside the cab, the crew is flying blind. They are the ones who usually get the blame in the court of public opinion, but the transcripts clear them of operational error in these moments. They were operating a 3-mile-long beast based entirely on the information given to them by the dispatch system. They didn't feel the vibration of the 23rd car. They couldn't smell the grease burning off the axle. They were trusting a safety net that had been cut full of holes to save money on maintenance stops. The train covered the next 20 miles, and during that stretch, the physics of failure took over. The heat didn't just rise linearly, it went thermal. The metal reached a plastic state. The bearing seized. The wheels stopped rotating and began to drag. At track speed, a locked wheel on a loaded railcar acts like a plow. It grinds the rail head, generating showers of sparks and immense lateral force. When the train finally hit the detector at East Palestine, milepost 49.81, the reading was catastrophic, 253 degrees above ambient. The alarm finally sounded in the cab. The automated voice shouted the defect. The engineer immediately initiated emergency braking, but physics is faster than reaction time. The bearing had already failed completely. The wheelset climbed the rail. The derailment wasn't a simple tipping over, it was a kinetic pileup of massive violence. The train accordioned. Tank cars carrying vinyl chloride, butyl acrylate, and other hazardous materials breached. They didn't just fall off the tracks, they were punctured, crushed, and ripped open by the momentum of the cars behind them. This is where the narrative lock-in shifts from mechanical negligence to chemical warfare. The fire started immediately. The friction that destroyed the bearing ignited the leaking chemicals. Within minutes, the scene was an inferno. But the real disaster wasn't the fire itself, it was the classification of the cargo and the decisions made in the command center as the sun came up. Official records show that the first responders were walking into a kill zone without proper information. The manifest data, the digital paperwork that tells firefighters what they are fighting, was sluggish, complicated, and not immediately accessible to the volunteers on the ground. They were spraying water on chemicals that react violently with water. They were breathing smoke that contained phosgene precursors. And while the fire chiefs were trying to figure out why the flames were turning strange colors, the corporate machinery was already spinning up. The focus shifted from contain the accident to clear the line. This is the dark heart of the railway business model. A blocked main line costs millions of dollars an hour in delayed freight. The pressure to resolve the situation, to get the wreckage out of the way, began to distort the decision-making process. The narrative began to solidify around the condition of the tank cars containing vinyl chloride. We were told they were unstable. We were told that a catastrophic explosion, a BLEV, boiling liquid expanding vapor explosion, was imminent. This fear became the currency of the negotiation. The railroad presented a solution that sounded like a mercy kill, a controlled release, a vent and burn. But looking at the pressure readings from those tank cars, data that has since been scrutinized by independent engineers and chemical safety experts, the story gets murky. The temperature inside the tanks was stabilizing. The pressure relief valves were working exactly as designed, venting small amounts of gas to keep the tanks from bursting. The data suggests that the imminent explosion was a worst-case scenario sold as a certainty. Why push for the burn? Because a cooling tank car takes days, maybe weeks, to offload safely. It requires specialized equipment, patience, and a halted main line. A vent and burn is quick. You blow the holes, you light the match, you burn off the product, and you scrap the metal. It is the fastest way to turn a hazmat site back into a construction site. The decision to drain 5 tank cars of vinyl chloride into a trench and set it on fire created a chemical weapon cloud over the Ohio River Valley. This wasn't an engineering necessity, it was an operational choice. The boardroom logic that set the detector threshold at 170 degrees was the same logic that decided a toxic mushroom cloud was an acceptable price for clearing the track. They locked in the disaster not just by letting the train crash, but by choosing the most destructive method to clean it up. As the black plume rose, visible from space, the narrative was fully secured. They called it a success. They called it a safety measure. But the residents watching the ash fall on their properties were about to learn that the railroad's definition of safety had nothing to do with human health. The crash was over, but the poisoning had just begun. The boardroom had voted, and East Palestine was about to be buried under the results. Stop believing the press release. Stop accepting the phrase abundance of caution as an apology. When you strip away the corporate PR and look strictly at the timestamps, at the frantic texts between engineers and the testimony given under oath, a different reality screams out. They didn't burn those cars to save the town. They burned them to clear the line. The narrative you were sold, that this was a heroic, last-minute decision to prevent a catastrophic shrapnel event, crumbles the moment you align the temperature logs with the boardroom's urgency to get trains moving again. This wasn't safety. This was speed disguised as salvation. The black plume that rose over Ohio wasn't just smoke. It was the physical manifestation of a decision tree rooted in liability management. As the sun rose on the days following the burn, the residents of East Palestine were told it was safe to return. They were told the air monitoring devices were registering clear. But the official records show a different story unfolding in the background, one of chaotic sampling methods and a desperate scramble to define safe in a way that didn't trigger a mass evacuation order that could last for months. The railroad needed the tracks clear, and they needed the town open, because every hour the main line remained severed cost millions in halted logistics. We see this priority shift in the way the cleanup was militarized. Heavy equipment moved in not with the delicacy of a crime scene investigation, but with the brute force of an excavation crew. Soil was turned, tracks were ripped up, and new ballast was laid down with blistering speed. In the hearings that followed, investigators would point out that vital physical evidence, the specific bearings, the melted sensors, the twisted steel of the tank cars, was compromised or moved before a full forensic reconstruction could be completed. The crime scene was effectively bulldozed to make way for the next shipment. This is where the true horror of the narrative lock-in begins. It wasn't just about hiding the cause of the crash, it was about controlling the definition of the consequences. Residents began reporting headaches, rashes, and a metallic taste in the air that coated their tongues like a chemical film. Yet the official channels remained rigid. The data they claimed showed no long-term risks, but if you look at the EPA's initial testing protocols, you see the gaps. They were testing for standard combustion byproducts, but the chemical cocktail released by burning vinyl chloride in an uncontrolled pit is far more complex. We are talking about dioxins, persistent organic pollutants that don't just fade away. They settle, they bind to the soil, they enter the food chain. The railroad's experts knew this. The internal emails suggest they were well aware of the chemical volatility, yet the public messaging remained steadfastly simple. The fire is out, the danger is past. It is crucial to understand the role of the tank car owner, Oxyvinyls, in this timeline. During the NTSB hearings, it was revealed that experts from the chemical company, the people who actually built the cars and understood the polymerization process, were trying to communicate a vital piece of information to the command center. They had data suggesting the temperature inside the tank cars was stabilizing. The chemical reaction was not running away, it was plateauing. An explosion was not imminent, but that information never made it to the decision-makers in time, or if it did, it was discarded in favor of the worst-case scenario model that justified the vent and burn. The governor and the fire chief were given a binary choice based on incomplete data: blow it up now or it blows up later. They weren't told there was a third option: wait it out. If digging into these transcripts and uncovering the mechanics of industrial negligence is valuable to you, helping this channel grow ensures we can continue parsing these thousands of pages of documents. The NTSB's final report was a scathing indictment of this communication failure. They explicitly stated that the vent and burn was likely unnecessary. Let that sink in. The mushroom cloud that poisoned a community, killed thousands of fish in the local waterways, and sent a plume of toxic ash across state lines did not need to happen. It was a choice made in a vacuum of information, driven by a corporate culture that viewed a blocked railway artery as a fatal condition, while viewing a poisoned town as a manageable liability. As the weeks turned into months, the narrative lock-in solidified. The railroad poured money into the community, millions for a new park, money for the schools, checks for the inconvenienced. In the boardroom, this is known as containment. It is a mathematical formula. You calculate the cost of litigation, the cost of EPA fines, and the cost of community payouts. You sum them up, and if the total is less than the revenue lost by shutting down the line for a proper, months-long remediation, you choose the payout. The stock price, which dipped initially, began to recover. The shareholders were reassured. The system had absorbed the shock. But the records from the town hall meetings paint a picture of a psychological fracture that money cannot patch. You hear the voices of mothers holding up medical records, asking why their children are bleeding from the nose. You hear farmers asking if their soil will ever be safe for crops again. And facing them are representatives armed with clipboards and rehearsed statements, citing thresholds and parts per million, speaking a language designed to deflect liability rather than address human suffering. The disconnect is absolute. On one side, visceral bodily reality. On the other, a wall of corporate jurisprudence. The disaster in East Palestine was not an anomaly. It was the inevitable result of the precision-scheduled railroading model pushed to its absolute limit. When you extend train lengths to 3 miles, cut crew sizes to the bare minimum, and defer maintenance on sensors to save on operating costs, you're removing the margins of error. You are stripping away the safety redundancies that stand between a mechanical failure and a catastrophe. The bearing that failed on that car didn't just fail in a moment. It failed over miles of friction and heat, screaming a warning that no one was positioned to hear because the systems designed to hear it had been thinned out to please the quarterly report. In the end, the boardroom vote that locked the disaster in wasn't a single show of hands on the day of the crash. It was a cumulative vote taken over a decade of budget cuts and deregulation lobbying. It was the vote to classify hazardous materials in a way that avoided stricter transport rules. It was the vote to fight the implementation of electronically controlled pneumatic brakes. It was the vote to prioritize operating ratio over operational safety. East Palestine is now a case study in the archives of industrial failure. The trains are running again. The whistles blow at the crossings and the wheels clatter over the new rails, carrying chemicals to the factories that build our modern life. The smoke has cleared from the sky, but the residue remains in the lungs of the town and in the soil beneath the foundations of their homes. The final tragedy is not that the system failed, but that the system worked exactly as it was designed to. It protected the asset, it cleared the blockage, and it isolated the cost. The railroad survived. The town is merely surviving. And as long as the boardroom math remains the same, the next East Palestine is already on the schedule, waiting for a bearing to overheat, waiting for a sensor to fail, waiting for the smoke to rise again.